Okay, thank you very much, everybody. So, my name is Andy Turner. I work for EPCC at the University of Edinburgh. We're the organisation that essentially runs the computational science and engineering support for the Archer 2 National Service. And that's where the funding and the support for this training session comes from. So today's session is really it's called Understanding Package Performance. In a nutshell, it's an introduction, an introduction to benchmarking on HPC, but done from the viewpoint not of thank you, George. It's not done from the viewpoint of not of somebody who's particularly developing their own software, but more how using basic benchmarking can be useful to people who run packages day to day or software packages day to day on an HPC system, and how they can use that to both make their optimize their workflow a bit and try to make it more efficient, and understand how they're using their HPC resources and make sure they can get the most out of them and the most benefits for their research out of the resources they're using. So what we try to do is look at the how does the HPC part fit within the end-to-end performance of a research workflow, how you measure parallel application performance, and what metrics are useful in what situations, and what decisions can you what practical decisions can you make based on those metrics in terms of improving your use of HPC. There's a couple of things to note. We're going to potentially make use of this Etherpad, which is linked from here, which is a collaborative text document that we can all edit. So if I switch over to that, you can type things there and we could share things. So typically what we use this for is we may use it in some of the exercises, but not so much in this course compared to others. But if there's useful notes or helpful notes for people that we come across during the exercise, or useful links, we can drop them in here, and people can then have access to them going forward, and we could save that for the future and make it more useful. If you have any comments or questions as we're going through, please do stop me, either by raising your hand or shouting out or typing something in the chat. I've got George here who's helping me out today, and also Zoo who will be around as well in case people run into any issues. Typically, we find that most of the sorts of practical issues people have is when they're first connecting to Archer 2. So we'll try and get that in pretty early so we can get those sorts of teething issues out of the way and get everybody going with the exercises and stuff. What we do, hopefully you understand the prerequisites for this course, is we're not going to teach you how to use the command line, how to submit jobs and all those sorts of things. Though we will cover some specifics about Archer 2 because it may be different from an HPC system you've used before, but generally we expect people to be pretty comfortable with those things and that sort of use of HPC system before they come on this course. So I'm not going to go into any detail. Of course, if people are struggling and you have questions about it, please feel free to ask and we'll do our best to answer them. Our aim here, in terms of the other thing I should say around the timings, there's a schedule here. The timing is going to be pretty flexible, except for one thing. I will stick just about exactly to where the lunch break is to give people some certainty about how their days split up. Okay, so you could expect whatever point we're at, and we'll go at a pace which suits you guys on the course and what's most useful for you, for your work and what you're interested in. I'm not particularly tied to getting through all of the material, though it's great if we can do that. But what I want to do is make it as useful to you as possible. So if that means going a bit slower, so we don't quite get through all the material in the day, that's just, I think there's no big problem with that. Okay. If we do finish before we've got to the end of all the material, if people have a real burning desire to have a go at the material that's later on that we didn't get to, if that happens, then we can always look to schedule a future, maybe an hour session or something to cover the last bits in the next couple of weeks or something like that for people who are interested. But I really do want to go at the pace that makes it useful for people, not just go at a pace to fit everything in, come hell or high water. So that's what we're going to do. in terms of a schedule. I'm going to go to the welcome section first. There's a few things I want to say. The main one is that around the code of conduct. We follow the Archer 2 code of conduct, which is something we put in place for the whole service. It covers everything to do with the service, people interacting on the machine itself and also at events. And it essentially amounts to being kind and respectful to other people on the course and using appropriate language when interacting with people. So we as people working on Archer 2 and the instructors here will try and meet all these things and using welcoming exclusive language and being respectful of you all, gracefully accepting criticism and focusing on what's best for the course and showing courtesy and respect to everybody else. And we expect that hopefully that all of you are happy to do that as part of the course as well, to make it as good a learning environment as possible for everybody. If you do think if there's a problem with what's going on, either with ourselves, the instructors, or with another attendee, then please feel free to you can get in touch with me. That you should be able to message me directly within the interface, excuse me, or you could complete this form here, and we will investigate and take appropriate action as much as we can to rectify those things, because we really do want this to be as useful and inclusive for everybody here. And finally, how we're going to teach this course. So this isn't going to be typical the sorts of lectures and practical sorts of course. We're going to follow. You may have been on carpentry's courses before, software carpentry, data carpentry. We're going to try and follow the same sort of model as they use in their training, which is we all work together through the training materials. So typically, what we'll do is we'll work through things, and there'll be practical stuff built into the session as we go through, and we'll have a go where I'll show you some things, and then we'll all try it together and we'll work our way through the material together, and hopefully that'll raise questions and we can try and help you out if you get stuck and things like that. If you feel we're going too fast or too slow, then please let us know, and we can adjust the pace for people. So please do let us know if you're struggling to keep up, or if you find we're going too slow as well. We will also, although it's we use it for the carpentry style, I should say this isn't a carpentry's lesson, and we're not part. This lesson isn't part of the carpentry's portfolio of material. The helpers are here, of course, and finally around feedback. Well, I've talked about feedback during the course in terms of pacing and questions and things like that. We'll also ask for some more formal feedback at the end of the course. Please do fill that in if at all possible. You know, the good points and the bad points really help us improve our material and move it forward, and we're always looking to make it as useful as possible. So any comments on the course, the training, the style, anything like that, things that didn't work for you are really useful to us, because we really do want to make this better over time. So can I just check everybody's happy with where we are before we get started with the actual material? Or does anybody have any questions before we get started? No, I'm not hearing anything. So what we'll do is we'll just get started. So just let me take a swig of water. My throat's a bit dry. Okay, so our first session doesn't have much practical work in it. It's mostly going to be me talking and just introducing and setting some context for what we're going to do for the rest of the day. So hopefully this will be the most talking bit that we'll get during the day, because you know, it's pretty boring listening to somebody talking all the time, and we'll do lots more practical stuff as the day goes on. But we wanted to set some context and understand, you know, where does HPC sit in the workflow, and what do we mean around getting performance improvements, particularly on the HPC side, and how they would impact people's scientific workflow. So throughout this, I'd like you, if possible, to try and keep your own research workflow in your head. You know, if you're using HPC systems, or if you're thinking of using an HPC system, if you're using HPC systems, that's great, because you'll have an idea of where HPC fits into your overall workflow. If you're thinking about using HPC systems, try and figure out which component of that workflow where the HPC is going to fit within that workflow. And before we start, I guess I should define a bit better what workflow I mean by workflow here. It's the individual components and steps you take from starting a piece of work to generating actual data you use to do research. Now, as that covers many things. As this HPC course, we're really assuming that the use of HPC is an integral part of the workflow. So a simple example might be something in a material science area, looking at crystal structures. Sorry, this is because in a former life before I started working for EPCC, I did material science. So this is the example that sort of naturally comes into my head, but hopefully it's pretty transposable into other areas. So you might have the steps of sourcing some sort of crystal structure from either some experimental data or previous modeling studies. You convert the crystal structure into an input format for modeling using a particular software package you may have not heard of called VASP. Define those input parameters for the final calculations, upload the input files to the HPC system, run the actual job on the HPC system, run the actual geometry relaxation, analyze the output to verify that the relaxed or optimized geometry is reasonable, run some calculations on that relaxed structure to generate some properties of interest or theoretical properties of interest, download the output for the HPC system to local resource for analysis, and then analyze the output from the calculations to generate meaningful results, which go into a research paper or a thesis, or however you end up sharing your data and publicizing your sharing your research. So this is a really simple example of a workflow, a research workflow, right? It's probably overly simplified, and actually, when you think about it and start to break things down to steps, it has more steps than you'd maybe imagine at first glance for something that is very simple. And you can also see that some of the steps might need to be repeated as required during the actual use of the workflow. You might try a variety of different input configurations for the calculations to try and explore and find what's a reasonable model for your system of interest. There's an exercise here that we'd usually do when we're teaching in person, but it doesn't work so well when we're remote and online as we are at the moment. But you can maybe bear in mind it might be a useful exercise for you to do at some point, is to try and break down your workflow into its separate steps and understand which one of them depend on HPC, which ones don't, and things like that, and understand in the context of what we're talking about here. So then, if we have our workflow broken down into some steps, we then need to understand, or not all steps are equal. Some of those steps will be worth optimizing and improving, and some of them will be less amenable to being optimized or less useful to optimize because they're so quick anyway. And this is, I guess, this is some sort of profiling of your work. Which components are the most time consuming and why? And the first question you ask yourself, we're going to talk the rest of this course about HPC, optimizing your use of the HPC part of your workflow, right? But it may be the case that when you analyze your workflow, you find actually that the HPC part is not really the most time-consuming step. So maybe it's not the one that's worth focusing all the optimizing effort on. Now, of course, things are a bit more complex than that, and you might find that even though it's not the most time-consuming step, you've still got a finite amount of HPC resource. So you really want to optimize how well you use, say, that amount of disk you're given, or the amount of core hours or node hours that you've been given. So it may still make sense to optimize your use of it, even if it's not the most time-consuming step, because you have to fit your work within the finite resource. But I guess what I'm getting at is actually it's useful to take the time to take a step back and think about these things rather than just diving into the workflow and doing things and thinking about what you actually want to do. So the analogous thing for whether, trying to decide whether things worth optimizing or not, a colleague of mine, David Henty, has this analogy he uses actually in explaining parallel performance, but it works just as well here, is to look at transatlantic flying. Sorry, this is a bit UK biased for people who aren't in the UK, is that you're often flying from the UK to the US. But that is a workflow in some sense. There's a number of steps. You travel to the origin airport, you drop your bag and navigate security control. You board the airplane and sit about for a while. Then you actually do the flying bit, travel to your destination, disembark, passport control and baggage reclaim, and you leave your airport to continue the journey. In our example, we're going to consider the fly components as we're looking at proving. For example, you could have a faster airplane. I know Concorde used to fly transatlantic and was faster than conventional aircraft. And there's talk about having supersonic aircraft again on transatlantic routes at the moment, commercial supersonic aircraft. So at the moment, say the components take the following sort of time. So steps 1 to 3, which is the getting actually onto the airplane, takes around 3 hours. So it's an hour travel to the airport, 2 hours to actually get onto the airplane, because you've got to navigate security control, and then there's all the sitting about, and then there's boarding and all that sort of stuff. And then the actual flight itself from the UK to US takes about 6 hours. It depends where in the US you're going exactly, but say 6 hours in this case. And then it's usually a bit quicker getting off, though navigating passport control could be quite it depends when you hit the airport and how many other airplanes have landed at the same time. So it may take 1 hour, say. So at the moment in this workflow, flying actually represents 60% of the time for the total workflow. Right? If we designed an aircraft that reduced the flying time to 3 hours, for example, Concorde, then we reduce the total time to 7 hours, and flying only represents 43% of the time for the total workflow. And any further reductions in the flight time, say we had a scramjet or something that was completely novel, even if we could eliminate it altogether and just had some sort of teleportation device that instantaneously transferred you, the benefit becomes less and less and less as the other steps in the workflow start to dominate, right? So these other steps haven't changed at all. So you're only reducing this one. So the less percentage the flying time becomes, the less impact it has on the overall workflow. So if we think back about our HPC workflow involving HPC, if the HPC components of the workflow is a low percentage of the total time, then the motivation for optimizing it, actually in terms of, I've mentioned other things, other reasons why you want to optimize it, at least in terms of improving the overall workflows, is not very high. Okay, so actually having some understanding of how much effort you should invest in the different steps is a useful place to start, because it will at least set your expectations about what you're actually able to do by optimizing the HPC part of your workflow. Okay, and this is the point I mentioned before. There might be other motivations for optimizing that part other than just raw time to completion. So one of the other things, as workflows I've said are generally more complex than the sequential steps we've talked about here. And to be able to optimize further, as well as understanding the components of the workflow that make up the workflow, you need to understand you need to have some sort of understanding of dependencies between the components. And by this I mean, which components of the workflow depend on outputs from previous components of the workflow. And it's not often true that these are strictly sequential. There may be later components that are not strictly dependent on completion of previous components, or there may be many copies of similar sequential workflows, or a combination of both. Let's go back to the simplified materials modeling workflow we had before. Right, this is hopefully this is the same workflow we saw before. It's always very sequential, but the difference now is that we're going to work on multiple crystal structures rather than just one. Okay. Now, what happens then in terms of our workflow? So for each crystal structure now, and there might be different calculations we need to do for each crystal structure. We source the crystal structures, we convert the crystal structures into inputs, and then for each physical condition, say we're looking at different pressures or different temperatures for the crystal, or different combinations of temperature and pressures, we need to define the input parameters, upload, run, download, analyze, and then combine those multiple analyses or outputs to generate the meaningful results from research. So now this shows some sort of dependency. So each of these steps of A to E could be considered as independent. I mean, they do need steps 1 and 2 to be completed, but once you've completed 1 and 2, each of these steps from A to E can be independent. So assuming we had 5 different crystal structures and 10 different sets of physical conditions for each crystal structure, we have the potential for running 5 times steps 1 and 2 simultaneously, and the potential for running 50 times steps A to E simultaneously. Now, of course, we can't always realize all this parallelism, because some of the potentially parallel steps may be manual, and there's often only one of you as a researcher, unless you work in a very big team. Typically, if you're working on a research project or a PhD thesis, you're working on your own, and you're not very parallelizable. But with some planning and thought about automation before you start, you may be able to exploit this parallelism and actually improve the efficiency of the workflow with some thought beforehand. And again, there's an option here. I would encourage you to maybe to do this after the courses. Have a think about your workflow in the context of these sort of considerations, and see if there are any opportunities for you to improve things there. Now, the problem with research is that research is exciting and interesting. That's probably the strength of research too. But it is a problem because it means the temptation is just to get stuck in and do interesting, exciting stuff, right, and just get going. But it is always worth taking a small amount of time at the start to think about your workflow, dependencies, and all these things to see if you can improve the efficiency and the overall time for the workflow. I'm not just talking about the HPC part here. With a bit of thought beforehand, you can design your workflow better. So for a bit of extra startup cost, you end up being much more efficient in your research workflow over the long term. And certainly, I think it's always worth thinking through and doing a bit of planning before. So for the rest of this course, we're really going to look much more closely about the performance of the HPC components, because this is really focused on HPC performance. And look at how we could use that, the information we gather on performance, to make decisions about how we can efficiently use the resources you're using. But as I've said above, making your use of the HPC side more efficient may not have, depending on how your workflow is structured, may not have a huge impact on the overall length of the workflow. But even if it doesn't, it should make you more efficient in the use of the resources you've been granted for use on an HPC system such as Archer 2. And I just want to flag that we'll see this later on in another form, is that this if other aspects of the performance, as we'll see later on, of the workflow comes to dominate, then optimizing the performance of one bit of it doesn't actually have that much impact. And there are actually theoretical understandings of this and what it means in terms of parallel performance of HPC applications that we'll talk about later on in the course. So you'll see this same issue rear its head again then, and I'll flag that when we get to that problem. So that's the sort of context of where we are. So what I wanted to do there was give an overview of potentially where HPC fits within an overall workflow. And before we go and focus on the HPC aspects, give you some hopefully some things and concepts to think about that around, how does this fit into your wider workflow, and what does it mean in terms of efficiency for your research workflow. What questions do people have there? Does anybody have anything they want to ask before we move on to the sort of logging into the system and starting to actually run things and look at the HPC aspects in more detail? No? The sound of my voice has put everybody to sleep. Maybe I should actually do a poll of how many people are still awake after I've talked for a little while. Okay, with that, so the next section we're going to look at is briefly, I'm just going to give a brief overview of what the Archer 2 system itself that you're going to be using for the rest of the day looks like in terms of architecture and putting it together, just so you have an understanding of what the compute nodes are and what the file systems are and things like that makes sense for when you're submitting and running things later on. And we'll try logging onto the system and try and debug any problems that people may or may not have there, because it can be a little bit tricky getting onto the system in the first instance. And then what I think we'll do probably after that session is have a break. And if people are still struggling to log on, then myself and George certainly can stick around during the break and make sure that everybody's logged on, so that when we start straight after the break with the actual running jobs and the actual doing stuff on the system, everybody's ready to go and is a position to be able to do the work with the material. Oh, so it says break here first, but we're going to keep going for the moment because I want to get the SSH connection out of the way, and then we'll stop for a wee while. So in this short section, I'm going to talk about what hardware and software is available on Archer 2 and how does it all fit together and how we connect to Archer 2. And the idea is that you have some idea of how the whole system fits together, which you understand what you're actually doing when you submit jobs and run things on the system, but also you get to the stage where login is working successfully. So that prepares us for the rest of the course. So the Archer 2 hardware, Archer 2 itself is a big set, is the service, right? And that includes all the people who work on it, all the components of it, such as this training, the service desk. We have an outreach component, the HPC system administrators, all sorts of people as well. But in terms of the actual physical system that sits at the center of the service, it's an HP Cray EX supercomputer, and it has a number of different node types. The ones that users see, at least on the current system that we're going to be using today, which is actually a smaller preview system of the full system. The full system itself is undergoing final testing at the moment before it's made available to users. But in terms of the preview system, we have the login nodes and the compute nodes. All of the node types have the same processors. These are AMD EPYC Zen 2, so these are Rome processors, each of them with 64 cores. All the nodes are dual socket, so there's two 64 core processors per node, so 128 cores, physical cores per node. This picture is actually for the full system. There's some components here that, in particular, the solid state storage is not available on the preview system that we're going to be using, and the data analysis nodes aren't available on the preview system that we'll be using. But there's the login nodes and the compute nodes. There's a fast parallel file system, which is called /work, which is available both on the login nodes and the compute nodes. And there's a more sort of normal storage system, which isn't high performance, called home, which is only available on the login nodes. When you log into the system, you end up on the login nodes, and the only way to access the compute nodes is to submit jobs via the SLAM batch system. Now, those jobs can be pure batch jobs, as in you write a script, you send it to the system, you can log off, go away, do whatever you like, and then come back again and get the results later. Or it can be interactive. So you can say, run this command on the compute nodes now, and it'll try and give you a compute node as quickly as possible and run what you want to run. And that's mostly the mode we'll be using when we're working on the system. We have a reservation in place for this course, so that things should run straight away, because there should always be nodes available for you using this course. Typically, you'd have to wait in the queue of everybody else. If I know in the setup section, it said that you can either apply for a new account on Archer 2 as part of this course, or you can use an existing Archer 2 account if you have one. If you're using your existing Archer 2 account, then the commands will be slightly different, but I'll highlight that when we get to the section on running things, because you'll have to use the standard short queue and short queue reservation to run straight away. But I'll make sure we highlight that at the time, and we'll put the right commands in the Etherpad, just so people have them handy. They are in the setup section in the course materials as well, but we'll worry about that when we get to it. And of course, you can download data from the login nodes to the outside world, but we're not going to do huge amounts of that today. On the preview system, there's 1,024 compute nodes, which gives us just over 130,000 physical compute cores. On the full system, which is undergoing testing, there's just going to be almost 6,000 compute nodes and over 750,000 physical cores. All of the compute nodes on the current system have 260 gig of memory, and they're all linked together using the high performance Cray slingshot interconnect, which is actually a type of Ethernet interconnect rather than the usual HPC InfiniBand or other things. And as I've said before, you can only access it by the scheduling system. There's two different storage systems, which I mentioned, home and work. Home's visible on the login nodes, work is visible on the login nodes and the compute nodes. So whenever we're running work on the system, we need to be in the work file system, because that's the only storage system that's available to compute nodes, and we'll see that when we come to run some stuff in a moment. When you initially log on, you'll be dropped into the home file system because that's where people's home directories are. Typically, the home file system is used for critical data because it's fully backed up, but it has smaller capacity, and obviously you can't use it with the compute nodes. Work is a parallel file system, which has high performance potentially, but isn't backed up at all. So they are slightly different use cases. One slight wrinkle I just wanted to point out here is it is called the home file system, and it does contain your home directory. The home file system is the storage system on Archer 2, and your home directory is the Linux concept of a directory you're placed into when you first log in. It's stored in the home environment variable and accessed with cd twiddle or cd tilde or just cd blank on its own will take you home as well generally. So there is a slight difference between the home file system, which is the actual storage appliance, and your home directory, which is defined somewhere within the home file system. And we'll see this later on. Everybody has their own home and their own space on the home file system, which is like home T01, T01 user, where T01 is your project ID. And for this project, it's TA036. So, and you'll have a username. So it'd be home TA036, TA036, and then your username. Similarly for work, it follows exactly the same pattern, except it has /work at the start. If you end up running into a problem when using the system where you're certain that the data exists, but when you run a job, it complains that it can't see the data, that is often a symptom of the data being on the home file system, which, as I mentioned, is not visible on the compute nodes. If you want more information on the file systems and how the whole thing fits together, there's the Archer documentation website, which has a lot of information there, which you can follow through. But what we're going to do now is we're going to try and log into the system. Hopefully, you've all registered for an account and have one improved. Just let me check there's no outstanding account requests. Oops, sorry, I've just gone to the wrong website. I will just try and check that there's nobody just waiting right now for access. No, so there's no outstanding requests for access at the moment. So hopefully everybody's either set up an account or has an existing account they can use. Okay, so some people are still registered, and that's fine. Follow the setup instructions to register for an account, and we can get that approved and get you logged in straight away. So we're going to actually try connecting via SSH. The login address is this thing here, login-4c. That's because it's the full cabinet preview system. To log in, you need both an SSH key and a password. The password you get given as part of this, your initial password anyway gets given to you as part of the registration process. The SSH key you have to generate yourself, and there's documentation on how to do that. If anybody's struggling with SSH keys and passwords and things like that, we'll hopefully pick that up where people try to log in, and the helpers and myself can help sort out those problems. We have a password policy. It's written down, but essentially the way the password policy works is you can have a really long password with no special characters in. So the classic, I don't know, many people might have seen the webcomic XKCD. They have a classic password thing, which is horse battery staple. That sort of password would be valid, but not exactly that one, because obviously it's famous for a webcomic. Or if you want a shorter password, you can introduce capital letters, numbers, special characters, and that shortens for each of those things you introduce. You can choose a shorter password, but it may be harder to remember. It's up to you which you prefer. So if you're at the stage of getting set up, let's try logging in to the system. So here it says you can use SSH, whatever your username is, login4c archer2ac UK. Now, actually, it's sometimes a little bit more complex than that because it depends where your SSH key is located. So my SSH key is not in my default SSH directory on my system, so I have to specify the location of it. So a more complete command will be SSH -i, which provides the path to your SSH key. And in my case, it's I've got because I have access to quite a few different HPC systems. I have a number of different keys. I have an Archer one, which I use for access to the system. So I give the -I option to SSH, the path to the public, to the private part of my key, sorry, and then my username, which is TA036, because it's for the, I've created one especially for this project. And then the name of the login address. So that's login-4c.archer2.ac.uk. And what this will do, or what this would often do, is ask you first for your passphrase. I think, is it password or passphrase? See, now I'm going to have to go back and look at the documentation again. It's the other way around. Thanks, George.
The other way around. It will ask for your password
first, then
and then your passphrase.
Okay. So this would normally ask for your Archer2 password, and if you've got just the first one you ever picked up from Safe when you first registered, it will then immediately ask you to change that password. So in fact, let me do that, because what I could do is I will request a password change for this account, so you can see what the whole password setup looks like from start to finish. So let me do that. I've asked for a new password, so that should hopefully give me a new chance to give me a new one-shot password from Safe to try out. So I'm just getting hold of that. So you can't see, I didn't want to share the web browser where I'm doing this, so because you could see personal details. So let's try that again. So I'm going to do the same command, ssh level. Okay, hopefully it'll ask me for my password. I'm going to enter the one-shot password I've got from Safe. Oh, and I wonder if that means I was too quick in picking up the password, so it's the old one rather than the new one. Let me reload that. And get my password again. Okay, copy that in. Try that again. What you see when you enter passwords. Okay, so that's right now. So what you see when you enter password is it doesn't actually show you typing anything. That could confuse people sometimes. It doesn't even show stars or anything like that. So it feels like you're not typing something, but you actually are. So the first thing it does ask me to change your LDAP password. That's just my login password. So it asks me to enter the current one again. So that's the same one that I've just picked up from Safe. Okay, so I'm going to put that in again. And then it asks me to choose a new password. So let me try typing a different password of my choosing. You have to enter that twice. Okay, so I chose a new password and then it let me log in to Archer2. Okay. Yeah, so if you've got your password wrong too many times, there is a thing that bans people for a short while. It's just for 10 minutes. So you just have to wait 10 minutes and then try again. The password from Safe is quite complex, usually the initial password from Safe. I find the easiest way to get that into the system is to copy it to the clipboard and then just paste it into the password thing rather than typing, and that avoids confusion between things like L's and ones and zeros and O's and those sort of things. So usually when I'm working with the password, the first password I get from Safe, I copy it into my clipboard and then paste it into the password prompt in my terminal. Let's get on. One thing you'll notice there is it never asks me for my password phrase for my key, which it normally would do, but I tend to use yeah, okay, that's a useful tip, George. Because I use what's called an SSH agent, my key's already loaded into my system, and I entered my password when I put the key into the SSH agent. So that means that I don't need to type the key passphrase when I log into the system, but you possibly will do. So what I'm going to do now is give everybody a chance to log in. I'm going to put up a poll so that people can see whether they've logged in successfully or not. If you are struggling with login, you're having problems and errors or have questions, feel free to ask for help in the chat or put your hand up and we can get myself or one of the helpers to come and help you out, and we'll try and get this sorted out. And then as soon as we've done that, we'll take a break, and we could use that time to get anybody logged in and things like that. So if let me put the poll up first, and then I'll say something else. On that poll, people can answer that. So I'm going to answer yes because I managed to do that. And we can help people out if they need it. So let me go and have a look at the original schedule we had. I'll understand the timings a bit better. So here we are. We were not supposed to have a break until 10:50, actually until 11:05. So if you've logged into the system successfully, then what we'll do is we'll use the rest of this time until the break's finished to get the people who are struggling logged in. Okay, so if you want to take this time to go and stretch your legs, have a break, get a cup of tea, a coffee, a snack, or whatever you want to do, then it is 10:15 now. So what I suggest is we give it maybe a half-hour break for people, and we come back at 10:45. Okay, so if you're already logged in and you're happy with where we are, or you don't have any questions, then feel free to take the time until 10:45 at least, and when we'll restart then. Okay. Right, let me look at help. Let's see what we've got. So Samantha, which password is the first one to ask? Yeah, it's a login password. So it'll be the one from Safe. Yes, you've got to pick up your one-time Archer 2 password from the Safe site first. So I can show that. Just let me show you what that looks like. I'll drag this across to here. So on Safe, hopefully you can see the Safe. It's a bit small. Let me zoom in a bit. So this is the Safe interface where you've signed up for a Safe account, and then hopefully you've got a login account. So if you go to login accounts, you just click on it rather than selecting one. I've got lots and lots because I've got accounts on different systems and various other things to help the business system. But here's my login account for this course, this ART TA 036 Archer 2. So if I click on that, and then it gives me some information. The account at the bottom, there are some buttons. It shows me which SSH key I registered in my account, but there's also a view login account password here. So I can click on that, and you'll be able to see this one-time password, but it doesn't matter because you've just seen me change it, so this password doesn't work anymore. If I look at that account password, it tells me this is my one-shot password for that account here. So that's the thing I usually copy and then paste into the prompt to get me to log in. And as you saw here on the prompt, so it asked me to enter that, and then as soon as I did that, it asked me to change it again. So I entered the same password again, and then typed the new password twice. Okay, and I'll go and approve your account now. Let me get rid of this from here, so that people can't see. Oops, I should be able to move that away. Come on. Ah, there we go. Got it. Okay, Owen, you should have an email from Safe showing with the saying your account's been approved very shortly, and you can get the password as we've shown you, and try and log in. As far as I can see, we're almost there. So where were we? So I think Samantha's just waiting for the fail to ban to reset, so you can try again once for the too many failed attempts.
Andy,
Mm-hmm.
I think you can work around the block if you have too many failed attempts by connecting from a different IP address. So if you have a VPN service, for example, and you join that, then actually you can continue to try to log in. It seems to block just one IP address.
Okay, that's a useful point. So
sometimes when I screw up on these training courses, I then log into the VPN and I can log in straight away without having to wait.
Cool.
Anyway,
Thank
Samantha's
you,
in, so it's less of a problem.
That's good. So Zongzi, have you managed to log in at all? I know Owen's just waiting for the account to come through for him to try. Okay. George, can I show the bash window again? Yes, of course. Here. So I used SSH. In my case, because my certificate is not in the default location, sorry, my certificate, my SSH key is not in the default location. The default location is usually something like, let me type, I'll just type it here on the command line. But it's usually something like that. If your SSH key is at that location, sorry, this is home directory here, then you don't need to pass the path to it. But if it's somewhere else, you do. You can always pass the path to it anyway. Okay. So I passed the path to my the private part of my SSH key. The public part went up to safe and to be registered against your account. Then my username and then the login address, which is login-4c.archer2.ac.uk. It should ask you your password from the safe, which you get from safe. Once, and then it'll ask you for your login LDAP password, which is the same password again, and then it'll ask you to choose a new one. And then it'll ask you for your SSH key passphrase if you don't have your SSH key in an SSH agent like me.